Okay, in this part 2 video we're going to compute some more slopes of tangent lines at curves and talk a little bit more about the vocabulary of that and go from there. Okay, so the tangent line at a curve again is the line through a point on a curve that goes in the same direction as the curve, right? So it really at this point should only cross the curve at one spot. If I zoom in a little circle here really close to this point, this line is only going to cross, it's just going to touch the curve and then keep going. It doesn't mean that it can't cross it at some other point on the curve, but in a little neighborhood it just touches the curve and keeps going. And as long as the curve is sufficiently smooth, we have a slope there and a tangent line that exists. There are some like strange curves, like if I have a cusp like this, there's no tangent line at this point where it sort of goes straight up and then it comes back straight down. It sort of pauses there. If you draw your pencil, it stops and then changes directions abruptly. So there's no tangent line here because there wasn't a smooth change in direction. For a tangent line to exist, there has to be a smooth change in direction at that point, right? On this smooth curve here, the direction never abruptly changes. If I have a piecewise function, there's abrupt change of direction right there. There's not going to be a tangent line in that abrupt change of direction. Over here, there's tangent lines because that's smooth. Over here, there's tangent lines and that's smooth. But abrupt changes of direction, we don't get smooth tangent lines. If the function's not continuous, maybe it jumps. Right, there's no tangent line either at this point or at the end point here because I can't say what's going on either side of that. You could have sort of one directional limits. Maybe I have got a tangent line there from the direction from the right, and here I've got a tangent line if I'm coming in from the left, but there's no tangent line at either of these points that satisfies both directions at the same time. Like same with this, right? I've got a tangent line coming in from the left looking like that, tangent line coming in from the right looking like that, but no bidirectional tangent line. Okay, so there can be really, really weird curves where you don't even have tangent lines from one direction or the other. Like if I have something that's just spiky all over, right? And if I zoom in further, it just looks even spikier on that little zoom in bit, right? And if I zoom in further there, it's spikier there too. Okay, these types of things exist, and there are no tangent lines, there's no derivatives, it's just smooth nowhere. Okay, so there can be some funky functions out there, but we're just going to talk about the nice ones. Okay, so let's do another example of finding a tangent line. Let's look at the graph of, let's say, the square root of x. And I want to find the tangent line here at, say, the point, if I put in 4, I get 2 out. So let's find the tangent line of the square root of x at 4, 2. Okay. If you remember from last time, we put another point here. We have this variable h that we use to say how far away from our focus point we are, right? 4 is where we're focused in the x direction, so 4 plus some little bit is how we indicate how far away from the focus point we are. And then I'm going to take the square root of 4 plus h as my output. Okay, so my average rate of change, my slope of my secant line here, right? The slope of that secant line is the change in y's over the change in x's, so that's the square root of 4 plus h minus 2 divided by 4 plus h minus h. And I have this square root of 4 plus h minus 2 over h. So in the last video we said we want h to approach 0, and whatever happens we'll call the slope of the tangent line there. Well, I can't let h approach 0 right now because I've got 0 in the denominator then. So somehow I have to make this look better, and I see that I've got this square root up in the numerator that maybe I can do some manipulation with and get things to work out for me. So I'm going to rationalize the numerator. I think we talked about that in one of these videos. So we're going to rationalize the numerator, which means I'm going to multiply by the conjugate. So I'm going to multiply the top and the bottom by 4 plus h plus 2 instead of minus 2, and I don't want to actually change the expression, so I have to multiply and divide by it at the same time. Okay, when I multiply and divide by it at the same time, I get this difference of squares on top, and I get this guy in the denominator still. So the difference of squares on top turns into, well, the square root of 4 plus h squared is just 4 plus h, and then I've got the difference of squares, so I have to square 2 as well. I take away 4. I have h, I have the square root of 4 plus h, and then I've got a plus 2 down here. That's kind of nice because now this plus 4 and this minus 4 cancel, and I'm left with h over h times square root 4 plus h plus 2. h's cancel. I've got 1 over square root 4 plus h plus 2. Okay, now I can let h get really close to 0, and I'm not dividing by 0 anymore. So as h goes close to 0 now, this slope gets close to 1 over the square root of 4 plus 0 plus 2 is 1 over 2 plus 2, 1 over 4. So my slope gets close to positive 1/4. So the slope of that tangent curve is going to have positive 1/4 as its value. Okay. Let's find this actual tangent line now. Let's find the tangent line. We found the slope. This was the slope of the tangent line. Let's find the actual tangent line. So we've got y equals the square root of x at x equals 4. We found the slope. We have the point 4, 2. So I have a point and a slope. To find the line, I'm just going to use point slope form. So I got y minus y1 equals m times x minus x1, right? And so I've got y minus 2 equals 1/4. That was my slope. X minus 4. Y equals 1/4 x minus 1, and then I'm going to have to add 2 to move this 2 from that side to this side, and then this distributed to both those pieces, right? And so I get y equals 1/4 x plus 1. And that's the tangent line. If I wanted to know the equation for this line here, the equation for this tangent line, that tangent line equation is given right there. Okay, that's all of 2.1, except for a few definitions. I want to talk about what these definitions are. Okay, so the slope of the tangent line is the derivative of the function at that point. So in this case, f of x equals the square root of x has a derivative of 1/4 at x equals 4. Okay. And we'll talk more about that language and that sort of vocabulary in the next section, but derivatives are slopes of tangent lines. Okay, so that's how we should think about these things. All right, see you in section 2.2.